Now in today's video, I'm going to go ahead and talk about the Cartoon Guide to Chemistry, summarize it a little bit, tell you my thoughts on it, and the fact that it is around a decade and a half old, if not 2 decades old. And would you look at that, copyright 2005. Copyright 2005. It's 2 decades old. It's a 2-decade-old book. I know, I'm a very old school person. But here we are. Cartoon Guide to Chemistry. This thing itself is timeless. No matter when you are reading it, it will be applicable to be pretty much anywhere. Chemistry that we've learned from thousands of years ago. Also back then they didn't call it chemistry, they called it alchemy. Are still applicable to this day. And in this video, I'll be talking about the Cartoon Guide to Chemistry. Sorry for the original video. Something went wrong during recording, so no sound was there. And this will be the re-recording. I'm costing my soul here. Let's go. The Cartoon Guide to Chemistry. Now, this is Craig Criddle. He's the one who actually wrote the book. And throughout the book, you get to go ahead and get this chemistry stuff explained by him, cosplaying as a wizard. And I'll be honest with you guys, chemistry itself is somewhat like magic. Some parts of it do feel like magic. Like this most recent science fair experiment that I've ever done was spraying fire, like actual fire, with like these alkaline metals to make them change colors. Like with like NaCl, you could change it to a very bright, vivid orange. With potassium, it also changed to another color. Yeah, pretty much that was a very fun experiment. I will probably not be uploading that to YouTube though. Another thing that I want to mention here is that because of that magicalness, that's why people have been addicted to chemistry for all the centuries. Chemistry itself is the study of little stuff, the hidden ingredients inside our world. As in the hidden ingredients, it's basically atoms and molecules and all the different recombinations that you get from those. Obviously, you can't exactly build stuff from just one thing, so you need to have separate things. Let's start off with our discussion with matter. Matter is made up of stuff. People pretty much knew about all that kind of stuff. What kind of stuff, though, people, that was what they were disagreeing about when this kind of questions were starting to appear. There were like 3 camps that people were fighting in. The first one was the atomists. They believed that everything was made up of all these fundamental particles. Basically, if you could cut everything as much as an infinite times as you want, you actually can't cut it infinite times as you want, because you'd eventually reach a limit where it can't be cut any further. And they called these little particles atoms. Another group pretty much thought that everything was made up of fire. Yeah, I'm serious. Like, there's this guy named Heraclitus, and he and his followers believed every sort of thing was made up of matter, because pretty much everything except water for some reason burned. Yeah, but atoms couldn't be seen, and like fire, really. So like Aristotle's model, the one that people have accepted for centuries, was pretty much the classic Avatar, Last Airbender kind of thing, where he believed and pretty much thought that everything was built out of water, earth. I should probably do green for that. Water, earth, fire, and obviously the last one, air. And yeah, that kind of makes sense to some people. Some people go ahead and say that some material compositions have all of this, or just a little mix of these two, and then that's pretty much how it works. Even in Airbender, that's how they went ahead. They did the Aristotle's philosophy into their element bending powers, that kind of stuff. But out of all these 3 ideas, for some reason, it was Aristotle's that became the most influential. And to be honest, I can see why. It would be pretty cool to just have anything just be a combination of these 4 elements, and as a result, you could technically change any dull old metal that's more common on the earth into something that's a little bit more rare and more valuable, like lead into gold, for example. So this is how alchemy went ahead and came to be. Alchemy, it said, was supposed to be just a pseudoscience that was to go ahead and create stuff out of other stuff, turn stuff into other stuff. Technically, that is possible. That is actually possible, but not in the way that they envisioned. Their idea is that we'll just add a little bit more earth, we'll add a little bit more fire, we'll add a little bit more water, but most of the time they just added a bit more fire by just heating everything up. Obviously, this was a a very hopeless quest, but it became very popular. And in Persia, there were like these two people named Jabir and Al-Razi who were pretty much creating alchemy stuff all the time. And they, instead of actually finding gold, so they did invent a bunch of good lab equipment that chemists would use in the future. And as a result, we want the hand to keep going on and on and on. Like, there was a German alchemist eventually named Hennig Brand who tried to actually go ahead and create gold from 60 buckets of his own urine. Now, in the end, his equipment all glowed in the dark. And he discovered phosphorus, but like, he wouldn't believe that he discovered an element. Instead, he just went ahead and said, I need gold. What is this yellowish glow in the dark stuff? I guess that is kind of useful, but boiling 60 buckets a year, that's probably not worth it at all. Anyways, so that's how it goes. We get this basic chemistry stuff, the alchemy and other stuff. Then we learn about air pressure and the fact, and people went ahead and proved that air pressure was an actual thing, and that's why these two valves wouldn't separate when you went ahead and made them into a near vacuum by pumping all the air out. When you did put the air back in, so it will pop like very, very easily. You know those times when you go ahead and take a syringe and then you draw the air out of some sort of container, you try to separate those containers, but then like you find it really, really hard. That's because air pressure is pushing inward, but there's nothing inside to push outwards and a balancing force. Only when these two are going ahead and are balanced is it easy to go ahead and break the seal and separate the two discs. One bad thing about air pressure, like air, is that the alchemists had no way of actually storing air. They could not account for air in any of their equations. In fact, some of them probably thought that, hey, maybe it's better to just let the gas out. No, unfortunately, no. We all know the three states of matter: solids, liquids, and gases, and with those, we can go ahead and create a bunch of combination of things, but I am taking a little too long in alchemy here, and I still have 4 more things that I want to talk about. Get ready for a 20-minute long video. Afterwards, we have modern chemistry. Modern chemistry itself is all the chemistry that you would learn in, say, advanced science, like advanced placement, GCSE, IGCSE, and the IB courses. You would learn all that. So obviously I will spare you most of the details. I told you about all the alchemy stuff because I find it very fascinating too. So we have a bunch of stuff that I would like to talk about, like the periodic table. The periodic table itself is a very fascinating creation. I'll have to say creation, it's not a discovery. Eventually, people did went ahead and accepted the atomic model theory because it did explain what everything in the universe was created of. So obviously, after they wanted to classify the few elements, they would need to go ahead and somehow organize them, and that's where our very, very friendly periodic table came into being. Some people went ahead and just listed them into a list, and obviously that's going to be a very, very long list. It's 118 elements, and then someone decided to turn it into a table. Obviously, the periodic table. The periodic table itself was created by this Russian dude named Dmitry Mendeleev. Dmitry Mendeleev allegedly here, I'm gonna have to say allegedly, went ahead and had a dream after like not sleeping for 3 days, trying to go ahead and organizing all of that, and then was able to go ahead and create the periodic table. Notable thing about it though is that he didn't just try to fill it into a list, he put in gaps. He was like, hey, there's a gap here. There's an element. This is going to be an element that's going to have these certain properties. And then someone went ahead and actually found that element in the future, but it didn't have the exact same properties. So Mendeleev was like, no, you didn't find the element. You found a version of the element, but you didn't find the pure element. Go do it again. Nobody obviously believed it for a bit, but then like eventually they did realize that Mendeleev was right and that germanium really did have the properties that he described, and that what they found was just a compound of germanium and something else. At least that's what I was told when I was young. Well, this is all the stuff that I've been told. And as a result, the periodic table of elements is something that exists to this day and is hanging up on my wall in my room. Okay, 2 things down. I have 3 more things that I really wish to really talk about. So, obviously, let me just do a crash course on atoms for you. You might know this in your basic high school chemistry or middle school chemistry too, actually, and some primary students actually do know all this stuff too. I know it because I learned all this in kindergarten. No, like seriously, I did learn it in kindergarten through YouTube. So there are atoms have protons, electrons, and such. The number of protons you have in an atom goes ahead, determines which element you are. Like you have 10 protons, that makes you neon, whereas if you have like 118 protons, you have the very, very unstable organosone, which doesn't even last a second to exist. All elements above 90 are not found. 90 protons are not found in nature and are all man-made. And some of them do last a significant amount of time, but like the rest usually just disappear after a few seconds. It's that unstable, but it does exist. We've confirmed that it does exist. It's just that it can't exist on Earth for a very, very long time. Also, one more thing I should probably mention here is that protons are really, really small, and that they're jam-packed in a nucleus with neutrons, and through that, after a very, very, very wide distance, like if the proton and neutron nucleus was this small, like I'm not sure if you could see it, but like if it was this small, like look here, it's this small, then the electrons will be all the way out of the screen, something like that. Now let's talk about thermodynamics. Thermodynamics itself is pretty much everything about chemistry that you need to know. I know I skipped a bunch of stuff like ionic bonds and covalent bonds and polarity and kind of stuff, but right now I want to do a crash course of this thing. Thermodynamics, an overview of it. Thermodynamics is just pretty much, as the name suggests, it's a bunch of heat. You go ahead and heat a bunch of stuff up, and then you go ahead and find out about everything in that. You also have thermodynamics equations that you have to do to find out like boiling points and melting points, and whether stuff are exothermic or endothermic reactions. Exothermic is like the reaction itself is releasing heat to the environment. Now that means that the product itself is losing heat, but the environment, the same that we are feeling, is gaining heat. That's why exothermic reactions actually feel hot, whereas endothermic reactions, like the product gains heat and as a result it feels cold. The environment that we touch it in feels cold. The actual thing though, it's really hot. And now we'll get to the fun part, organic chemistry. Now, this is where biology starts to come into play in, but that's it for an entirely different video. Organic chemistry itself is the chemistry of life. It's the stuff that goes ahead and defines all the stuff that you would go ahead and figure out. And the number one element in organic chemistry that you need to know is carbon. Pretty much everything in life is made up of carbon. Even your pencil lead, your cells, your cells, and then the plants, the fossils, the bones, they're all pretty much in some way related to carbon. I know they're not made of carbon, but carbon is the thing that we definitely leave behind. We date how old fossils are by going ahead and looking at how much carbon that they have left, because some people and some animals have a certain amount of carbon, and carbon's isotopes have like these half-lives, and how much of those half-lives are remaining and how long it will take for that next half-life to happen is how we date stuff. Albeit the older it is, the less precise it is, but it's better than nothing. I'm not going to explain organic chemistry to you. I'm just going to tell you that it's about a bunch of carbon and it's about your life. You can learn all this stuff at your school, in your advanced placement classes, your GCSEs, those kind of things. But for now, I'm going to finish this video with my thoughts on the cartoon guide to chemistry. I hope you guys actually did enjoy my brief fist explanation of all of chemistry. I skipped a lot of stuff, but in the end, this 2-decade-old book, it technically 21 years now because it's 2005, is still relevant to this day. Chemistry itself is a science that goes ahead and shifts, and we still learn new stuff about it, but all the fundamentals that everyone has to learn to at least understand new stuff is all the same. The things that the alchemists have created several thousand years ago for trying to find gold and finding up this bunch of glow in the dark stuff. That is the same equipment that we use in chemistry to this day. The beakers, the flasks, the titration kind of gears, the little pipettes that we use, that kind of stuff, that was created by the alchemists. The Greeks may have been wrong, at least believed the wrong things, as in like water, earth, fire, air, that kind of stuff, but at least they did their best to understand the world in the way that they could understand it at the time. Now, their chemistry might have sucked, but at least their biology was somewhat better. And yeah, next time I'm going to talk about the cartoon guide to biology. So in the end, Larry Gonick and Craig Criddle, they have created an incredible book that's literally timeless. Crashing on an island with an airplane or getting lost on Treasure Island, that's timeless stuff. That stuff exists for like several decades and possibly centuries, and it is still relevant to this day. We are still fascinated about those kinds of stories, and we are still learning this kind of stuff to this day. In fact, AP Chemistry itself has pretty much all the stuff that Craig Criddle has written and Larry Gonick has drawn. So next time you're on, like, you want to read an educational comic book with words, like a bunch of words in them, go ahead and read the Cartoon Guide to Chemistry. I hope you guys enjoyed this episode of Hanjun Chan, and I'll see you next time. Thank you for your precious time.